Okay, lesson 11, page 158, problem number 41. You have a roller coaster, and at the bottom of the first dip, the person feels the seat pushing up on their tushy with a force twice as great as their weight force. So basically what that's saying is, right down here at the bottom, if we look at that person right here, there's two forces acting on that person. Their weight force is pulling them down. And you have the normal force pushing up on them. This is F sub G down there. Maybe I should draw a new picture there. So basically, right there at the bottom, their weight force is pulling them down, but the seat is pushing up with the normal force. And basically, they say that that normal force pushing up on them is equal to twice their weight force. So that's equal to 2 F sub G. Now, they say that the bottom of that dip is part of a circle. So basically, if this is the center of the circle, the car is going through a circular path there at the bottom. And they tell you that the radius of the circular path right there is R. That would be the center of that circle. And if R is 20 meters, they're asking you what's the tangential velocity of the roller coaster at that point. So guess what formula we're going to start off with? Yeah. You could start off with F net equals MA. But that net force in this case is going to be providing a centripetal force. And that's going to be causing a centripetal acceleration. And what's going to be the expression for the centripetal force at that bottom point? Well, before that, don't make that substitution yet. In terms of Fn and Fg. Fn minus Fg.
Isn't that just going to equal Fg?
Yep. Fn minus Fg equals m. And what's expression for the centripetal acceleration? But we were told in the problem that the normal force equals twice the weight force. So we know that this is going to become 2Fg. So we were told that that normal force is equal to twice the weight force minus Fg equals m v squared over r. So basically this is just going to reduce to Fg equals m v squared over r.
Which I got down to mg equals
mg equals m v squared over r. And what happens to the m's?
They cancel
They cancel out. So you're left with G equals V squared over R. So V is going to equal the square root of GR. So it's going to be the square root of 10 meters per second squared times 20 meters. Say it again?
Like, can we leave it underneath the radical so it would be
No. In physics, you always should crunch it out and then put the number sig figs. Don't leave it in radical form.
Unless, of course, you're going to use that somewhere.
Exactly. Point taken. Very true. So if that was you riding on the roller coaster and you weigh 100 pounds, when you go to the bottom of that little part right there, you would feel like you weigh how much? 200 pounds. If you were sitting on a bathroom scale and you look between your legs there, it would say 200 pounds at that moment. And you would feel it yourself, you would go, oh.